Hello everyone and welcome to the review for electrolysis. So let's get started. The first question here is telling you what is meant by electrolysis. Actually, electrolysis is the breaking down of ionic compounds when molten or in aqueous solution. Okay, so this is actually what is meant by electrolysis. Okay, this is the breaking down of ionic compounds when molten or in aqueous solution, and this happens by the passage of electricity. Okay, so this happens the um, by the passage of electric current, by the passage of electric current. Okay, so this is the definition of electrolysis. Okay, breaking down of ionic compounds when molten or in aqueous solutions by the passage of electric current. Then the second question, name the positive electrode and the negative electrode. The positive electrode is called anode, okay, and the negative electrode is called cathode. When molten lead bromide is electrolyzed, what is produced at the cathode? So at the beginning, you should be aware that when you have molten, okay, so here no water exists. Okay, molten means that this is only the chemical substance, lead bromide, that exists. So it is only the compound without having any water in this example. Okay, so molten lead bromide is electrolyzed. What is the product at the cathode? The product at cathode would be the lead. Okay, let me correct this, has to be capital letter. Yeah, this is the lead produced at the cathode. And why is this happening? Because lead is the positive ion here. Lead is the positive ion, while bromine is the negative ion. So the first part of the compound is the positive ion, which is the metal, and the second part is the non-metal, which is negative. Well, what is produced at the anode? So produced at the anode is the bromine gas. Okay, the bromine gas is actually bromine gas is produced at the anode. Okay, so Br2, the bromine gas is produced during electrolysis of molten NaCl. So this is also molten NaCl, so again no water here. Write half equation at the cathode. So again, at the cathode, which is negative, I have to think about the positive ion, which is the sodium, the first part, as I told you, in the compound. So sodium actually, as an ion, it has one positive charge. How did I know that it has one positive charge? Because it belongs to the first group in the periodic table, so it has one positive charge. So the sodium is reduced at the cathode, which means it gains electrons and it change into sodium atom. Okay, why does electrolysis not happen in solid NaCl? In solid, actually, this question is to let you understand that solid NaCl has no the solid solid state has no free ions, because it's solid. Okay, a solid state has no free ions. That's why electrolysis happens by having the molten or aqueous solution, okay, of the same element. So the ions are free only in case, as I said in the beginning, here in the molten or aqueous solutions. Okay. And electrolysis of aqueous copper sulfate, and this is the part that we did in the lab. Okay, inert electrodes that we used were the graphite. Okay, the graphite that we used in the lab. Okay, this is called inert. Inert means it's unreactive. Which ion is discharged at the cathode, copper or hydrogen, and why? So in this case, I'm gonna say that copper ion has been reduced at the cathode, okay, instead of hydrogen. Why? As copper is less reactive than hydrogen, okay? Because copper is less reactive than hydrogen, so in this case, actually, copper is reduced. Which gas is released at the anode? And if you remember, oxygen gas, that the same that we did at the lab, oxygen gas is released at the anode. Oxygen gas is released at the anode. And how this happen? How does this happen? Because of the oxidation of the hydroxide ion. The hydroxide ion, as I told you, is oxidized, losing electrons by the formation of 2 water molecules plus 1 oxygen and 4 electrons. These are the electrons that are lost. So the hydroxide ion of water is oxidized, producing this oxygen that we saw, the bubbles that you saw at the anode. Okay. State 2 the factors that affect which ion is discharged during electrolysis of aqueous solution. 2 factors that affect which ion is discharged during electrolysis. So the 2 factors here are talking about at the anode and the cathode. Okay. So let's start at the cathode. At the cathode, we said at cathode, okay, the least reactive ion will be reduced. Okay, the least reactive ion will be reduced. This happens at the cathode. Okay, the least, not the last. Least reactive, which means it has less reactivity than the other one. Okay, while at anode, the hydroxide ion will be always oxidized unless there is a concentrated halide exist. Concentrated, and this is the rule, halide exist. So at anode, the hydroxide ion will always be reduced. Let's correct this. Will always be reduced, oxidized, unless there is a concentrated halide exist. Okay, this is the rule. Okay, unless there is a concentrated halide exist. What is the concentrated? Concentrated has to be written in the question. Okay, so this is a concentrate, like this example. We will do it now. Okay, and the halide as a negative ion, we're talking about the Cl negative or the Br negative or the iodine. Okay, fluorine is very, very reactive. We don't use it in electrolysis. Okay. The eighth question says predict the products at each electrode during electrolysis of concentrated aqueous sodium chloride. So whenever you have aqueous solution, okay, so you need to know that this is the compound. So the positive ion of the compound and the negative ion of the compound exist, right? And the hydrogen ion of water exists as well, and the hydroxide ion of water exist at the anode. So both of these, both of the positive ions will move to the cathode, right? And both of these will move to the anode. Okay. In this case, which one is getting reduced and which one is getting oxidized? Actually, hydrogen is getting reduced. Why? Because hydrogen is less reactive than sodium, and here chloride ion will be oxidized. I chose both of these according to the rule. The chloride ion, we just said the rule that hydroxide will always win. But this is but when we have the case of concentrated halide, the Cl exists, as I said here, so chlorine will be oxidized. Okay, so in this case, at each electrode, I'm going to say at the cathode, hydrogen ion will be reduced, forming hydrogen gas. Okay, so at the cathode, the hydrogen ion will be reduced, forming hydrogen gas, and at the anode, chlorine ion will be oxidized, forming chlorine gas. Okay, so this is Cl ion will be oxidized, forming chlorine gas. Okay, guys, and this is depending on the rule, because chlorine is a halide. Chloride ion is a halide, and it actually oxidized in this case because it is written in the question concentrated, as I said here, unless there is a concentrated halide. Okay, so I think it's clear now. Let's I will just try to write down here the half equation. The hydrogen ion, when it is reduced, it accepts one electron and it change into hydrogen, right? But hydrogen is a gas. It exists always as diatomic, so I have to add here 2 diatomic molecule. So here I will add 2, and this I will add, and here I will add 2. Why? Because this is a diatomic molecule, and in balancing the equation, it finally appears by the same equation that you see right here. Okay, and in the chlorine also, chlorine has a negative charge, so it loses its electron at the anode and forming the chlorine plus electron. Okay, the chlorine actually also is a diatomic molecule, so I have to add 2 here and 2 and 2, so now the equation is balanced. Okay, and the half equation, we'll have question about it at the end of this worksheet. 9, predict the products at each electrode during electrolysis of dilute. Okay, dilute means not concentrated, so take a note about this. Dilute means not concentrated aqueous chloride. So in this case, we have the same ions, like the same the previous question, but now it's dilute, means it is not concentrated. So in this case, hydrogen will be reduced and the hydroxide ion will be reduced. Okay, because there is no concentrated halide now. It's dilute, means water is more. We have more concentration of water in the dilute solution. Okay, and here in this case, chlorine and hydrogen are produced. Okay, guys, so I'm gonna say that at the cathode, again, hydrogen ion will be reduced, forming or producing hydrogen gas. Okay, the hydrogen ion, and at the anode, OH hydroxide ion will be oxidized, forming oxygen gas, according to the equation that I told you to memorize it. Okay, OH ion, OH ion forming oxygen gas. Okay, so I'm gonna add here hydroxide ion, hydrogen ion, hydrogen ion, chloride ion, and oxygen gas O2. Okay, will be produced at the end. In the electrolysis of aqueous copper 2 sulfate using carbon electrode, describe what happens to the concentration of copper sulfate solution. What happens to the concentration of copper 2 sulfate during the electrolysis? Okay, Actually, we did this in the lab, okay? The concentration of copper 2 sulfate decreases by time. Why? Because copper is reduced during the electrolysis, okay? Copper ions is used, we said, and it deposited on the negative electrode as you saw it in the lab. So the concentration of copper sulfate decreases by time. Why? Because of the loss of the copper ions which are reduced at the cathode. The mass of each electrode. The mass of each electrode, it means that the mass of the cathode increases. Why does it increase? As copper ions are changing into atoms which are deposited on the cathode, the negative electrode, okay? The mass of the cathode increases as copper ions are changing into atoms which are deposited on the cathode. The last part, writing the half equations for reduction and oxidation. So this is considered to be like a practice for writing down the half equation. Write the half equation for reduction of hydrogen ions to hydrogen gas. That's very easy, right? Reduction means gaining of electrons. So we write down electron, okay, like this, because if this is gaining, and it turns into atom, changing from ion into atom by gaining of electrons, because hydrogen ion is actually in this case means that it has lost already one electron, okay? By gaining one electron, it turns back into an atom, okay? But as I said several times before, hydrogen is diatomic molecule. It exists naturally as diatomic, like H2. So we need to add 2 and 2. So now the equation is balanced. Right, have equation for the oxidation of hydroxide. Oxidation of hydroxide ion, I told you, whenever hydroxide ion is oxidized in any example of electrolysis, memorize this equation that I will write it right now and write it away, write it directly, okay? 4OH negative produces 2 water molecule plus the oxygen gas plus 4 electrons, okay? Whenever the hydroxide ion is oxidized, it produces 2 molecules of water, 1 molecule of oxygen, and loses 4 electrons. Easy, just write it down. This is balanced equation, write it balanced like this, okay? Write the half equation for oxidation of chlorine. That's also so easy. Whenever you have oxidation, write the arrow immediately after the ion, okay? In the case of oxidation. And in oxidation, as I told you before, the electrons are written at the right side of the equation. So chlorine forms the chlorine atom plus electron, and again, chlorine is diatomic molecule. I have to write it down in this form, Cl2, because I added 2 here. I'm going to add 2 electrons here and 2 here. Very easy, okay? Write the half equation for the reduction of copper, okay? Copper to positive reduced means gaining of electrons, so immediately plus electrons, it turns into copper atom, and that's it, okay? Because the copper ion is actually missing 2 electrons. When it accepts 2 electrons, it turns back into copper atom, okay? In the electrolysis of molten lead to bromide, write the half equation for the cathode reaction. So this is molten. Actually, we did this in the, at the beginning. The molten lead bromide. So at the cathode, I'm gonna choose the lead to be at the cathode because lead is the positive ion, bromine is the negative ion. So the negative ion, the second part of the compound, will be negative, and it is attracted to the anode. So the half equation for cathode. So the lead 2, it tells you lead 2, which means 2 positive. Okay, two positive, whenever you have a two positive ion, immediately it will accept and gain two electrons to produce the lead atom. Okay, the same as the copper here. This like metals, copper, iron, metal. This is a lead atom for metal. Okay. Right, that's equation for the anode bromine. So the bromine, again, bromine has one negative charge. Okay, in this example, if you don't know that bromine has one negative charge, go to the periodic table. I will give you the periodic table. Actually, bromine belongs to the 7th group in the periodic table, and you know that previously that group 7, they whenever they have a charge, they have a charge of -1. Okay, and group 6 has charge of -2, and group 5 has charge of -3. Okay, so the bromine, whenever have negative, immediately write the arrow. Okay, bromine turns into bromine atom. Okay, and loses this electron. It loses this electron plus electron. Okay, but bromine again is diatomic molecule. Bromine is diatomic. I can't write it in this way. I have to write it Br2. Okay, because it's a diatomic molecule. It exists naturally as Br connected to another Br. So I'm going to add 2 here and 2 here, and now the equation is balanced. Guys, this is all the objectives and the questions that you might have in the quiz tomorrow, inshallah. Study well. Review this video like several times. Go to the notes that we did in the class, and also your booklet. Okay, now you have many resources with this video to help you out with the quiz tomorrow. I wish luck for all of you, and I wait for all of you to get the full mark, inshallah. See you tomorrow. Bye bye.